Okay, so here you're given a graph, and the biggest thing about these types of problems is that you need to make sure that you really take a look at the type of graph you are looking at. So in this case, they're telling us that they have given us the graph of f of x. So this is the original graph. So really, you could tell me just by looking at the graph, if I point to an area, like if I pointed right here, and I ask you, is f of x increasing or decreasing here? Clearly decreasing. I mean, this is f of x, right? Concave up or concave down? Okay, so when you're given f of x, it's obvious, especially when you're given the graph. All you have to do is look at it. But we want justification. We want to know why this is happening. So here, when we're looking at the sign of f prime, what you're looking at is the slope. Okay, because if this is f of x, you're looking at the slope. You're looking to see if the function is increasing or decreasing over that given interval, and then your justification would be if the slope, meaning f prime, is positive or negative. So when you look at interval a to b, is the slope positive or negative? Positive. That means f of x is increasing. So here the sign is positive. You would say f prime is greater than 0. What's f double prime? What are we looking for again? I forget. Oh, concavity. So we're looking at concavity. And is this concave up or concave down? Definitely concave up. That means the sign of f double prime is going to be positive. Okay, f double prime is greater than 0. So let's look at B to C. Okay, slope, positive or negative? Definitely positive, right? From here to here? Okay, positive. F prime is greater than 0. F double prime, we're looking at the concavity. Positive or negative? Concave up like a cup or concave down like a frown? Down, for sure, right? Frown. So this is negative. F double prime is less than 0. You guys do C to D. Okay, from C to D, slope, positive or negative? Definitely negative. Okay, so my function is decreasing. Negative. F prime is less than 0. What about concavity? Negative. Down. Okay, questions when you're looking at f of x. It's pretty straightforward, but things are going to change when you're looking at f double prime or f prime. So we need to make sure that we're clear on that. So here you're given an example that is an algebraic example. And what we're looking at is the intervals over which my function, this function without a calculator, is increasing and decreasing, concave up, concave down, and any x coordinates of the inflection point. So this is actually the easier type of question because you only need to give x equals. And you actually, bless you, find that when you're doing these two. So really, your question can be grouped. Here, A and B are going to be done together because you're using f prime. C, D, and E deal with f double prime. Okay, so break this question into small pieces. So the first thing we want to do is identify our critical numbers from the first derivative. So we're going to take the first derivative. So this is what? 12x cubed minus 12x squared. Okay, and we want to find our critical numbers by setting the first derivative equal to 0. How do I factor this thing? Yep, greatest common factor of 12x squared times, what is this, x minus 1 is equal to 0. Is that right? Okay, critical numbers, what are they? X equals 0 and 1. Okay, here we're using f prime. We put 0 here and we put 1 here. Okay, what do you notice about the multiplicity of these two factors? Say it one more time.
They're different.
They are different. One is even and one is odd. So far all we've had are odds. So now you're going to get to see what an even, how that works. So we always start on the number line from the far right. I look at the multiplicity. The multiplicity of 1 is even or odd? The multiplicity of 1 is even or odd? It is odd. So I'm just going to write it right here so that you guys can look at it later. So that means that when you go from interval to interval over that odd multiplicity critical number, the sign will change. So from here to here, your sign is going to change. And I'm going to put a delta there. That just means the sign is going to change. Everybody good with the notation? So just to prove it, okay, I'll do this quickly. Plug in 2. 2 squared is 4. That means this is positive. 2 minus 1. This is positive. Didn't we say we would start with a positive? I'm more concerned about going from here to here that it's going to change to negative. Okay, so I'll plug in 0.5. I don't care about the value. 0.5 squared is positive, correct? 0.5 minus 1, negative. So what is this going to be? Okay, so this works based on what I've told you so far, correct? Okay. Here's the thing. The multiplicity for the factor of 0 is even, correct? So if this is an even multiplicity, that means from here to here, the signs do not change. I will prove it. So what does that mean the sign's going to be? Should be negative. So let me plug in, I don't know, negative 1. Negative 1 squared, positive. Negative 1 minus 1 is negative. What is this? Negative. Okay, so again, the explanation is longer, but once you know the pattern, that would have been a lot quicker, right? Bless you. What would you do if you forget? Are you going to panic? No. What do? Just plug in the numbers. Okay? We freeze sometimes. We're testing. Oh, wait, I can't remember. What am I supposed to... Just plug in the numbers. And remember, you always want to plug them into the factored form. Okay. So now that I've gone through that whole spiel, now what we need to look at is the interval or intervals on which f is increasing. Can someone tell me what they or it might be? 1 to infinity is correct. 1 to infinity. And what's the justification, sir? You got that? Yep. F prime is greater than 0. Questions? Okay, now, do you guys notice that the interval from negative infinity to 1, they're both negative, true? Okay, but do we know what's happening at 0? Do we know exactly what's happening at that critical number 0? Increasing? No, we have no idea. We don't know what's happening. So if you remember from the previous, when it alternated and went negative, positive, negative, or whatever it did, we used parentheses. So we were not including the critical numbers. So you cannot write the interval from negative infinity to 1 because we don't know what's happening at 0. We have no idea. We have not investigated that, so we just have to let it be. So when you write this interval, it's negative infinity to 0, and you can put a union in there, that's a 0, and from 0 to 1. And this would be because f prime is less than 0. Okay, so just be careful with that because we're not using brackets. Had we been using brackets, then we could have written just one interval. Okay? All right. Questions on increasing, decreasing before we move down to concavity and inflection? Okay, so what do I do for concavity? Take the second derivative. So I have f double prime of x is equal to. Should I take the derivative with the first one here or the second one? If I use the second one, I would have to use a product rule. That's a lot of work. Less work, right? So 36x squared minus 24x. Now what? Factor what? Sure. So let's take out a 12x. That leaves me with 3x minus 2 equals 0. Okay, we have a critical number of a fraction. People freak out. Don't, because you know the pattern with respect to multiplicity. Multiplicity of both of those factors, even or odd. So that's the easy one, right? You start on the far right-hand side, and what do you do with the signs? Start with positive and alternate to the left. Okay, so first of all, what are my critical numbers? 0 and 2/3. Okay, so here, this is f double prime. You've got 0 and you've got 2/3. You said this is positive, negative, positive. What do you do if you don't trust it? Plug in, but we're not going to do that. Okay, concave up. Help me out. I'm sorry, not all at once. Yes, negative infinity to 0. Anywhere else? Oh, 2/3 to infinity. Justification? F double prime is greater than 0. Okay? Concave down. 0 to 2/3. Justification? Perfect. Okay. Now, you are asked for the x coordinates of the inflection points. You do not have to give x comma y. I just want x equals. What are we looking for to identify inflection points? Sign changes from F double prime. Where do the signs change? 0 and 2/3, and you would just say F double prime changes signs. This is your justification. Okay, questions before we move to the next problem? Everybody doing okay? I know it's a lot. Yep. Okay. So, remember in that very first problem at the top, I highlighted we were given the graph f of x? Now we're taking a look here. It says given the graph of f prime. So we are not given f of x. Okay? But f prime can give us a lot of information, but you have to be careful how you use this graph. I cannot look at concavity. I can't say, oh, the graph is concave up everywhere. This is f prime. We are talking about f of x. So it's, if we're talking about the derivative going in this direction, it's this way that we're talking about. Do you see what I'm saying? So what we have to look at is the location of f prime in relation to the x-axis. Okay, so if f prime's graph is above the x-axis, that means your y values are what? Positive or negative? Positive. If f prime is positive there, what is f doing? Increasing. Okay, so you really have to think about what you're doing. So here we are talking about f prime right here is greater than 0. So then when we're looking at below the x-axis right here, what are we looking at? Right here, yep. F prime is less than 0. What about here? What is this telling us? Yeah, f prime is equal to 0. Okay? Alright, so in F and G, we are looking at the location of f prime with respect to the x-axis. It's really important. So if this is f prime's graph, how do I look at f double prime? What is the relationship of f double prime to f prime? Ah, I heard it. The what? Yes, it's the slope. So how many times does the slope change on this graph? Just once. Where? At 0. So what could you? How could you describe 0 for me? What would it be? Yes, absolutely. Does everyone understand why? So here, my slope of f prime changes from negative to positive at 0. So we could say x equals 0, f double prime changes signs. But really, we're going to answer all these questions. In order to answer these questions, you have to remember what you're looking at. Okay? Because it's very easy to confuse. So when we're talking about increasing, how many intervals are there where f prime is above the x-axis? And we're going to do this just to clarify. I heard it a little bit louder. It would be 2. Can you tell me exactly where they are, please? That is correct, and I could say that f prime is greater than 0, or you could say f prime is above the x-axis if you wanted to be very specific. Those are both the same thing. Okay? All right, what about decreasing? What are we looking at? Yes, negative 1 to 1. It is where f prime is below the x-axis. So from negative 1 to 1, f prime is less than 0. And you basically told me concavity. Concave up from where to where? concave up. No. No, it's not. I heard it. Say again. 0 to infinity. This is f prime's graph, not f. Remember, we're talking about where f is concave up. Do you see? Okay, so this is from 0 to infinity because f double prime is greater than 0. So then from negative infinity to 0 would be where f double prime is less than 0. Okay, that's where we have to be really, really careful to describe what we're looking at and what we're talking about. Okay.